Alright, chemistry students, welcome back. I'm finally on the mend and finally feel ready to post another 5-minute video on your chemistry instruction without having to hack up a lung, hopefully, so let's go ahead and get started. This video is going to be on using the mole in the way we do in chemistry. So from the last video, we should remember that 1 mole is a number, the mole is a number, and that number is 6.02 times 10 to the 23rd things. It is a huge number of things. And we use a mole in the same way we utilize a dozen. Just like a dozen is 12 things, a mole is 6.02 times 10 to the 23rd things. And we asked ourselves the question in the last video, well, why would we choose such a huge and bizarre number in order to measure our atoms or molecules? And the reason is because a mole of atoms or a mole of molecules happens to be the exact number of atoms that makes it so that 1 mole is also equal to the atomic mass of whatever substance that we're weighing. So, for example, if we had a mole of sodium chloride molecules, a mole of sodium chloride molecules means that we have 6.02 times 10 to the 23rd sodium chloride molecules. In the same way that if we have a dozen sodium chloride molecules, that would be 12 sodium chloride molecules. So a mole means we have this number of things. We have 6.02 times 10 to the 23rd of that thing. And the reason that number of molecules is convenient is because a mole of sodium chloride molecules, we know from the periodic table, weighs exactly 58.5 grams, which we can then weigh out on the balance like we did at the end of the last video. So how do we know that it weighs 58.5 grams? Well, we get that from the periodic table, from the atomic mass of the substances. We can see that sodium, over here, weighs 22.98, so we'll call that an even 23 atomic mass units. And chlorine, over here, weighs approximately 35.5. So the sodium chloride molecule in atomic mass units weighs 23 from the sodium plus 35.5 from the chlorine, and together the molecule weighs 58.5 AMU. Conveniently, that also means that a mole of that substance weighs 58.5 grams. So any substance with a chemical formula, we can look on the periodic table, figure out how much that 1 molecule of that substance weighs in atomic mass units, and that will be equal to how much a mole of that substance weighs in grams. This also helps us contextualize chemical equations. So, previously, again, we've been reading this as 1 molecule of nitrogen gas plus 3 molecules of hydrogen gas will react to create 2 molecules of ammonia. We could also, we know that this is, the only thing that's important about these coefficients is the ratio between them. We know that for every 1 molecule of nitrogen gas, we need 3 molecules of hydrogen gas, and when we do that, we'll produce 2 molecules of ammonia. However, it doesn't need to be exactly 1 molecule, exactly 3 molecules, and exactly 2. It can be any number of molecules as long as the ratio of the molecules is in the ratio of 1 to 3 to 2. So, for instance, we could have 1 dozen nitrogen gas molecules and 3 dozen hydrogen gas molecules, and that would create 2 dozen ammonia molecules. What we choose to use in chemistry often is we use moles of molecules because that amount can be easily weighed out on a balance. So we could just as easily read this: 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas to produce 2 moles of ammonia, which is what we'll do very frequently when reading through our chemical equations from now on. So utilizing the mole kind of works like this. Moles works like this bridge between how many molecules of the substance we have and how many grams of the substance we weigh out. In order to, if we know this, if we know how many molecules of the substance we have, we can figure out how much that number of molecules weighs by using moles. And if we have a certain amount of a substance weighed out in grams, and we want to figure out how many molecules that is, we can figure that out, again stepping through moles. What we cannot do is go directly from grams to molecules. We can't bypass this process. It can't happen. So what we do is we have a conversion factor between moles and molecules and between moles and grams of a substance, and we will use that and our dimensional analysis skills that we built at the beginning of the year in order to convert. So the conversion factor we have between moles and molecules is simple. We know that 1 mole of any substance is equal to 6.02 times 10 to the 23rd molecules. And between moles and grams of a substance is equally simple. We know that 1 mole of any substance is equal to the atomic mass of that substance that we can figure out from the periodic table. So let's see if we can't apply that to some of our problems here. Actually, I'm going to take a quick break. We're going to get a calculator so that we can do this without me having to use my phone. And then I will post that in the next video. Thank you very much. See you in the next video.